the first computer was invented, technology has come a long way. This transformation has been made possible by the incredible technology that goes into semiconductor chips. These chips are the engines that drive today's technologies, such as servers, the cloud, the Internet of Things, artificial intelligence, and virtual reality. We will explain the small but important role that photon control plays in the semiconductor chip manufacturing process. These chips are manufactured on silicon wafers. There are typically hundreds of chips made from a single wafer. Semiconductor chips are made by creating tiny electrical circuits on the silicon wafer through processes called etch and deposition. Thin coatings of insulating and conducting materials are deposited on the wafer and then etched away using a corrosive charged gas called a plasma, leaving the desired circuit pattern. During the etch and deposition process, there are several equipment parameters that must be tightly controlled to ensure adequate chip yield. One of the most critical parameters is wafer temperature. The entire wafer surface must be controlled to within a fraction of a degree throughout the process. Otherwise, imperfections can occur, causing some of the chips to fail. A 1% yield loss can cost a chip manufacturer tens of millions of dollars per year. This is where photon control comes in. We provide fiber optic temperature and position sensors for deposition and plasma etch systems, which enable the tight process control required to achieve high yield and equipment uptime. As an example, let's look at the use of our temperature sensors in a plasma etch system. We use phosphor fiber optic sensing technology to measure the wafer temperature. Unlike conventional thermocouples that are unable to provide accurate temperature control in the presence of a strong magnetic field found in a plasma etch system, our phosphor probes are accurate and stable, even under these extreme conditions. For this application, temperature probes are placed at specific locations across the electrostatic chuck, which supports the wafer. Each fiber optic probe has a proprietary phosphor material at the tip. After shining a pulse light source on the phosphor, it re-emits the absorbed light down the optical fiber to the converter, where the temperature is calculated. The temperature from all probes is then sent to a controller, which maintains a uniform chuck temperature at all times. The result is that all chips on the wafer are processed at the same temperature, which is critical for high yield. Photon Control's proprietary fiber optic sensing technology and customer-centric philosophy allows chip makers to meet critical process control requirements, even in the harshest environments. The result is higher yield, uptime, and profitability, and that is how Photon Control plays a small but important role in making possible some of the most revolutionary technologies of today and tomorrow.